Just speaking that atomic code. Researchers have figured out how to turn atoms into ones and zeros, or code. To understand this further, we need to understand code and technology. Basically, a series of ones and zeros can be written and sent to parts of your computer for different actions to occur. For instance, 1, 0, 1, 0, 0, 0, 1, 1 might mean to your audio systems to play a B-sharp note, but to your display it might mean like a yellowish green sort of color, and in text is like a lowercase z. But 0, 1, 1, 1, 1, 0, 1, 0 might mean a G-flat note, a reddish purple, and an uppercase Q. The more ones and zeros, the more data you can store, and the more possibilities just in general. That's fine and dandy. However, the problems start when you have a set number of ones and zeros possible. In other words, a set storage. We experience this problem all the time. Whenever you run out of storage on your phone, you're experiencing the problem of having a set storage. Whenever whenever your computer runs out of storage, you're experiencing the problem of having a set storage, namely a smaller one. But this problem happens because in the hard drive or in other storage areas, in order to make a 1 or a 0, we magnetize a really, really small area. A northerly magnetized area might be a 1, and a southerly magnetized area might be a 0. We fit as many of these areas to magnetize in a certain space, right? But if we try to fit more in this certain space, then the hard drive kind of becomes a little unstable. And the 1s and the 0s, they just sort of flip. You might have a 1 turn into a 0, and a 0 turn into a 1. And that's not good. You might have a picture of your cute dog, cute lizard, or bird, doesn't matter, and it might turn into what looks like a 4th grade drawing of your bike, or a black picture of nothing, or a white picture of nothing. So that was limiting our data storage. But researchers from IBM now know how to magnetize atoms, and they know how to keep it stable. This is done with rare earth metals called holmium, and these sit on a sheet of magnesium oxide at a temperature below negative 450 degrees Fahrenheit, so practicality is going to be a problem. And holmium has many unpaired electrons that create a magnetic field. These electrons are close to the center of the atom to prevent outside interference. That is what makes the stability. To magnetize the atoms, a pulse of electric current from the tip of a magnetized scanning tunneling microscope is used. This is a microscope used for the smallest of the smallest structures and samples, and it works on the atomic scale. This same microscope is used to read the atoms to determine if a holmium atom is a 1 or a 0 or a north or a south. The researchers also created a 2-bit hard drive, 2-atom hard drive, with this technology, and these research predict if scaled up, this technology is 1,000 times more data dense. So you might think that's great, but so what? What does this mean for me? Well, estimates show things like all the music from Apple's library fitting on the size of a penny. And it goes beyond ridiculous storage capacity in all devices and into AI. AI uses an absolute ton of data to operate, learn, and it has to reprogram. Think about less limits to you and your ability to store data, and less limits to future technology and AI. Whether you use that 16 terabyte phone to troll, that 500 terabyte Xbox to game, or that 2,000 terabyte computer to subscribe to me, the future of data seems very attractive, because magnets, they attract. Well, that went south. This has been Everybody's Science. I hope you enjoyed. Please comment, like, and share this video. Don't forget to subscribe. And lastly, life is the experiment, and you are the scientist. Thanks for watching. Check out some of my other videos and click that sexy picture of me to subscribe. Click that picture of my friend Matthew to check out his channel. And lastly, click that rectangle to see the rest of the playlist.